Hi, and welcome back. What do you say we do some chapter 9 here? This is actually not a very long chapter. What we're going to do here in this chapter is we're going to review some of the content related to perception. You have probably noticed, I think, that there's a lot of perception-related content in this class, a lot of the history of psychology, a lot of the underlying philosophical content that we have been talking about have been related to perception, has been related to whether we can trust our senses, how does perception work, and also this question of how do we go from sensation to perception, and what is happening between sensation and perception. That's a big theme in chapter 6 when we talked about those 4 steps in the perceptual theory. There seems to be some general agreement about steps 1, 2, and 4, but there's a lot of disagreement about step 3. All right, so step 1, again, there's something out there in the world. We're going to perceive it, but what we receive is information or data about that object is a bunch of sensations, right? So we can think of it in modern neuroscience terms. We know something about how light stimulates the rods and cones in the eye, so we can talk about visual sensations in terms of the individualized responses of rods and cones that are coding information in the light about brightness and wavelength or color. But all of that individualized data about light coming into the eye and activating receptors and being coded as brightness and color, all of that data doesn't by itself tell us what it is we're looking at. It doesn't tell you that you're looking at a dog or a cat or a person's face or a car or a tree. It just tells you about the intensity and other values of the light, the wavelength of the light at various locations in the visual field. It's essentially psychologically meaningless. And of course, we've also talked about it in other ways. We've talked about ambiguities in retinal images. That was a big thing for Barkley and Locke and Lotz and Helmholtz. The idea is that the visual input is inherently flat and two-dimensional, but we still perceive a three-dimensional world. So it does suggest that there's some incompleteness in the visual input. It's usually referred to as the poverty of stimulus argument, right? The idea is that the stimulus that we receive from the world is impoverished and incomplete and missing a lot of stuff. But we nevertheless perceive a rich perceptual world. That is, our visual experiences and all of our perceptual experiences are very complex, rich, detailed. How do we get all of this rich, detailed, complex perception despite the poverty of our stimulation? The argument, of course, is that there must be something happening between the stimulus, which is step 2, the sensation, which is impoverished, and the richness of perception, which is step 4. So what's in step 3? What's in between? That is the mysterious process. And we've seen arguments about bottom-up processing. We've seen top-down processing. So again, the bottom-up, that's the British empiricist, Locke's theory of ideas, associationism. The top down would be right here on this slide, Kant and his innate categories. This is more of an active interpretive process. The idea is that the mind and the brain is actively interpreting the sensory input to figure out and interpret what's happening. And very similar, Helmholtz had offered a theory like that too. In using this kind of active top-down processing, it's just based on past experience instead of Kant's innate categories. But we're recalling Kant here for a reason, because Kant's ideas were very influential and are going to be a direct inspiration for the Gestaltists. So I want you to remember that's what Kant is talking about here, the two things, right? The innate part, that's quite a bit, heavy towards the rationalism side of philosophy there. And then the idea of an active interpretive top-down process happening in perception. Well, I guess I probably could have went to this slide too, because this slide is also a review of a lot of those perceptual theories, right? We've seen the British empiricist bottom-up approach. Also passive want to make sure you realize why it's passive, right? The idea is that it's really just governed by the laws of association. We don't need an active interpretive process. It just happens on its own, driven by the incoming data. That's why bottom-up theories are also sometimes called data-driven theories. Kant gave us a more rationalist top-down approach. Lotz and Helmholtz were kind of a hybrid, right? Because they don't appeal to innate knowledge, just a blank slate, right? But they still use top-down processing based on past experience. When we were talking in Chapter 8 about some of the early experimental psychologists like Wundt and Tishner, people who actually called themselves experimental psychologists and not physiologists like Lotz and Helmholtz, they didn't have a lot of theories. You know, the philosophers and theorists have a lot of theories and ideas about what might be happening in step 3. But Wundt and Tishner were trying to take a more scientific approach and actually study it. Hence where we get something like Tishner's introspective approach, his structuralism, where he is presenting images and asking people to analyze those experiences down into their elemental sensations so that they could sort of empirically report on what the organizational process of perception actually is, right? Didn't work out very well, but at least that was the idea. So now that we have thought about all of that, we can now get to the Gestaltist, and we've gotten ourselves up into the 19-teens, 1920s here, so well into the 20th century and getting closer and closer to modern psychology. And what the Gestaltists are arguing here, they're very influenced, as I had emphasized prior, by Kant, is that this process that's happening in step 3 is not something that we can be conscious of. So they clearly disagree with Wundt and Tishner here, that we would be consciously aware of this perceptual process. It would be more akin to Helmholtz talking about it as a form of unconscious inference, right? Unconscious processing. So to them, there's no point in trying to study how this process works. But what they can, or what they think we can do, is we can study the output of it. Namely, that means studying perception, because we're going from sensation to perception with something mysterious happening in between. They're not going to get overly caught up in what's happening in between, but what they're doing is they're noting the difference between sensation and perception. They're noting, again, what I said earlier about how impoverished the sensations are compared to how rich perception is. And by comparing these two things, they would be able to draw some pretty, perhaps obvious conclusions about what's actually happening between these two steps, because you can tell what's been added in. If there's something present in perception, if there is a perceptual judgment that someone reports in a perceptual experiment, but that perceptual report is based on something that is not found in the sensations, that tells us something about what's happening internally. One thing I also want you to draw a connection with here is back in Chapter 8, we talked about the phenomenologists like Husserl and Brentano. And the Gestaltists are definitely using a phenomenological approach to perception, because they are not asking people to report on their sensations, right? They're asking people to report what they see, right? So using the picture of the cow, like with Tishner's study, Tishner doesn't want people to name it because he calls that the stimulus error. He doesn't think it's interesting. But the phenomenologists, that is exactly what they want you to do. They want you to describe, tell me, what do you see? You see a cow in a green field kind of stuff. So phenomenologists are not interested in trying to strip perception down into its basic parts and bits and pieces. They really want to know what it is that people are seeing. In fact, the famous claim that you probably have learned in association with Gestalt psychology is this phrase right here at the bottom: the whole is more than the sum of its parts. That, I hope it's all coming together here, that is a phenomenological statement, right? Phenomenology, again, is the study of whole, meaningful, conscious experiences, not without trying to break them down into meaningless bits and pieces, right? And so the whole of conscious experience is more than any kind of sum of little bits and pieces of meaningless structure, as Tishner would describe it. And because the Gestaltists were specifically interested in studying perception, they would actually have another statement parallel to that one. Perception is more than the sum of sensations, right? So the perception represents the whole, and the sensations represent the parts. So of course, sensations as parts play some role in determining how and what we perceive. But what we perceive is more than just that. There's something else that's added in here. Let's take a look at some specific examples here. My picture has moved around. Let me move Max Wertheimer up a little bit. So this is Max Wertheimer. He's really the creator of the Gestalt school in psychology. He was interested in studying what's called the phi phenomenon, which is just a fancy way of talking about moving pictures, right? They were invented in his time, right? The idea is that films, movies in that day were a sequence of still images, right? So think about that. In any movie, there is no actual movement happening on the screen. What's happening is that a still image is projected to the screen, and then very quickly it is replaced with another still image that is slightly different than the previous one. And then again, that one is replaced with another still image. And this sequence of images is being projected in sequence on the screen at a very rapid rate. In fact, something that we've learned in this time since is that the best ideal rate to present the images is at 30 times a second, or 30 hertz, or 30 frames per second sometimes. And that generally is enough to lead to the perception of a smooth movement. If you do it slower than that, the movement doesn't appear smooth and continuous. It appears kind of choppy, right? So anything at least at 30 times a second is good enough to be perceived as smooth. Faster is better. You can go to 60 frames per second. And you might see this kind of number on things like cameras, right? If you have a digital camera that can make movies, if you want to have a really smooth motion, you want to have a camera that records at 60 frames a second, or maybe even 120 frames per second, so that you can capture really fast movements. That's what this is all about. It's based on Wertheimer's research on the phi phenomenon. So what he's doing here is he's basically creating a simple kind of animation where he presents an object on one side of the screen, and then he takes that image away and he replaces the image with an object on the other side of the screen. So you might think of it as just a dark bar appearing on the left side of the screen, and then it disappears and reappears on the right-hand side of the screen. And then they alternate back and forth, right? The bar appears on the left and then appears on the right, and then on the left and then on the right. And then Wertheimer is controlling and studying the rate of alternation of the position of this bar on the screen. And what he finds is that once he speeds up the rate of alternation to something like 30 times a second, people will report that suddenly this no longer looks like a bar that just disappears from one location and reappears somewhere else, right? It's just jumping back and forth. And it becomes smooth, continuous movement, that it's actually traveling left or right across the screen, even though it's not, right? It's not actually moving. It never occupies a position anywhere in the middle of the screen, and yet people report that they see it actually just going left and right, back and forth across the screen. So here we can use the whole is more than the sum of its parts, or perception is more than the sum of sensations. Here we have the perception of motion that's happening here is more than the corresponding sensations, because there are no sensations of movement in these displays, right? Nothing actually moves on the screen. It's just a stimulus that's just alternating and flashing its position, but it doesn't actually travel anywhere. So people are seeing something move when there's nothing actually moving. So this is a good way of saying, okay, look, we know because we've created this display, what's in the sensation. And now we can ask people, what is in your perception? And we can compare people's perception versus the sensation. And we can say, look, something has been added in here. Motion has been added in. This tells us about what's happening in the brain, right? So this is a phenomenological approach that helps us understand what might actually be happening with perception. following that, became very popular to study other kinds of illusory things. So what we might call the phi phenomenon here is illusory motion, right? But we can also talk about illusory contours. A contour is an edge, right? So here's some pictures of illusory contours. On the left is the famous Kinesa triangle. So you could take a phenomenological approach to this and ask people, tell me, what do you see? And people will report, well, I see 3 circles, right? 3 dark circles. And I see one dark outline triangle. And then I also see another kind of opaque blue triangle floating on top of all of these things, right? That's a phenomenological report to say that I see one blue inverted triangle floating above another dark triangle, as well as 3 circles. But if we analyze this image in terms of what's actually there in the sensations, what we'll find is that there are none of those things actually are present, but most especially that blue floating triangle is not there. Think about what it means to talk about the contour. For there to be a contour or an edge for a triangle here, if you follow my mouse pointer, if you can see it, I hope, there would have to be a change in brightness along this boundary here, right? Because there would have to be a boundary between this is the outside of the triangle and this is the inside of the triangle, right? Outside, inside, outside, inside, right? But it's not there. It feels like you could see a boundary, but if you really look, there is no boundary. There's no change in brightness between the inside and outside of the triangle. It's simply not there. So it's an illusory contour. It's perception of shape when there is no shape, perception of an edge when there is no edge. Likewise, over here, we get some illusory contours. Again, people will report phenomenologically speaking, I see a ball studded with spikes, but there is no contour for the ball. Over here, people will report seeing a pyramid surrounded by concentric squares and also some circles. But again, that pyramid is not there. There's no edges or contours for that pyramid. Perception is more than the sum of its sensations, right? So what's actually happening here? So the Gestaltists have an idea that all of these kinds of phenomena are the result of something called the law of prognance. Prognance means good form. I think technically it might mean something like pregnant or bursting forth in German. And it means, giving birth to good form, of trying to create good form. So the argument here, what do we mean by this emphasis on good form, is that the brain has an innate tendency to prefer to see certain kinds of shapes and forms over others. This is why we are recalling Kant, because this innate tendency to want to see certain kinds of shapes and forms as good forms, that's reminiscent of Kant's ideas of these innate categories, that we have these innate tendencies to perceive certain things in certain ways. So this is a top-down process in the sense that we have innately a predetermined idea of what constitutes a good form, and that meaningfulness, that preference, is now imposed on incoming sensory patterns. And to the extent that these patterns can be reconciled with these innate ideas, then we're going to see the triangles or the balls or the pyramids, because those would be part of the good form. How does this potentially work here? Well, the Gestaltists also talk about these organizing principles. These are the mechanisms that are actually at work inside the brain that help the visual system kind of impose patterns, to find patterns here. I have 4 listed here. This is not a comprehensive, thorough list of all the Gestalt organizing principles, but it's enough for us to just get a little taste of it. We don't need to go down the rabbit hole of the real details of Gestalt psychology, but I have a slide for each one of these. Let's think about how proximity works here. So on the left-hand side, you have a picture of dots, just a bunch of dots. It's a field of dots. There's 36 dots, right? 6 rows and 6 columns. if I were to try to find a pattern there, and again, that's what we're talking about here with the Gestalt approach to perception, is that the brain likes to find certain kinds of patterns. It's a pattern seeker and a pattern imposer on the world. Is there a pattern amongst this field of 36 dots? Well, not really, right? You could try to see it as 6 horizontal rows, but that's a pattern that you can kind of force on it, but it's not exactly stable. That is, you can see it for a second and then it goes away. You could also see it maybe as 6 vertical columns, but again, that's not a stable pattern. You could perhaps even see it as concentric nested squares. So maybe, for example, a little 2x2 square in the middle surrounded by a 4x4 square. And then that in turn is surrounded by the outer 6x6 square. But again, not stable. But now if we change this field a little bit by just putting a little gap in between, in this case, column 2 and 3 and column 4 and 5, suddenly one particular pattern becomes much more stable. We start to see it as 3 columns with 2 dots across in each column. We cannot any longer see 6 horizontal rows, nor can we see nested squares. We can only see the 3 columns. The argument here is that there's nothing inherent about this configuration of 36 circles on the right that says that those circles that are part of the new columns actually somehow belong to each other. They're just dots on the screen. So they don't belong to each other in the sensation or in the image. Rather, they only belong to each other in our perception. And that comes from the rule of proximity, right? The fact that they are now closer to each other, these dots over here, are now closer to each other than these dots here in this wide gap, tells us that the ones that are close to each other must now somehow be connected. And again, that's only something that is true within our visual interpretation of the image. We could do something else here. We could take our 36 dots and we can then color them in different ways. So now we have no longer the ability to see 6 columns or nested squares. We can only see 6 rows, right? Because now, again, according to the image, there's nothing inherent in the image that says that the white circles or the black circles somehow belong to each other, are all connected in some way, but nevertheless, that's the way we perceive it. So again, that pattern is an interpretation happening within our perception. Here's a pretty different example. Closure is the rule that we like to close broken forms. And so the idea here is that in this image, there are no closed, complete shapes and forms. It's all just splotches. But nevertheless, you can see something, right? You can see a dog sniffing the ground. You might even say it's a Dalmatian. So it's kind of weird that some of the splotches are just not part of anything, and some of the splotches are helping us see the contours of the dog's body, and others are actually actual splotches on the body of the dog, right? Continuity is the principle that we prefer to see continuous forms over discontinuous forms. So here we have another field of dots. How do we interpret this field of dots? Well, proximity might come into play here a little bit, because we might start to think, okay, this dot up in the top left might be connected to this dot just below it because they're close to each other, as opposed to being much farther away from these dots over here in the top right. So, okay, proximity is going to help us keep these dots connected in a certain way. But what happens when we come down here, if we start tracing this top left sequence of dots down to the middle? And now we're asked with the next question here, which dots belong to which other dots at this point right here in the center? Are we going to continue following this line all the way across? In which case what we might do, and of course we'll do the other thing over here for the one on the top right, coming down to the middle and coming across to the bottom left, what we might report seeing here, again, a phenomenological judgment, is that we see 2 strings laying across each other. because we prefer to see the lines moving in a continuous direction. But the argument here is that that's not an inherent part of the image. Why don't we perhaps see this sequence in the top left come down to the middle and then double back and stay down on the bottom left? And likewise, coming from the top right, we could come down to the middle and then double it back and stay on the right. But those would be discontinuous, more jagged changes of direction as opposed to more smooth, continuous changes of direction. And per the organizing principle of continuity, the brain prefers to see continuous change of shape over discontinuous. It's part of the law of provenance. It's part of what constitutes a good form. A good form is a continuous form, not a broken, jagged form. The Gestaltists also have a little bit of an early neuroscientific idea in terms of how this might actually work. If you recall, Kant had even suggested that his innate categories are somehow embedded into the brain, that the brain holds a special kind of dual status as being a physical organ as well as the thing that creates our consciousness and therefore shapes our consciousness based on these innate brain categories. And the Gestaltists just change it up a little bit and talk about the brain fields. So what is a brain field? Well, you could maybe trying to use your imagination, think about a field of activity spreading across the brain. And now that we know some things about action potentials and synapses and the whole degree of connectivity across the brain, what is sometimes described as the brain's connectome, we might imagine a field in terms of a pattern of activity spreading across the entire cortex. But the Gestaltists didn't really understand it quite like that. In fact, their idea of brain fields was inspired by Einstein. And so Einstein uses field theory to explain gravitational space-time. And the idea of, he talks of gravitational fields and how they give shape and structure to the universe. And so the Gestaltists were trying to make the same claim that there are similar kinds of mathematical fields at work within the brain, and that this is where our consciousness comes from, is that the brain is capable of creating these fields, and that these fields correspond to our consciousness. But what's also important here is that just like in Einstein's physics, gravitational fields shape and structure space-time, here, brain fields shape and structure consciousness in a very direct, literal way. So what that means, for example, let's think about an example of something. Let's think about, well, what we've used in this class a lot is the concept of circles and perfect circles. So let's think about a perfect circle. Now that you're thinking about a circle, try to visualize it, try to picture one in your mind. We might ask, is there anywhere inside your brain an actual circle? Typically, our answer would be to think, no, there's not an actual circle anywhere inside my brain. It's just a pattern of activity in my neurons that enables me to somehow visualize a circle. We don't know how it works, but we think, oh, it must work somehow, right? We might likewise think, for example, that if I were to draw a circle on a computer screen and save that file in a computer's memory somewhere, I could ask, is there a computer anywhere, is there a circle anywhere inside the computer? And again, kind of a common sense answer would be no, of course not. There's no circle inside the computer. It's just code, right? It's a bunch of numbers that provide instructions to the computer for what kinds of pixels should be activated when it wants to draw this image. And then it draws a circle. But as far as the computer's memory and processor is concerned, it's not a circle stored inside of it, just some numbers, right? Codes. And so we tend to take the same approach to thinking about the brain, that all the activity of the neurons is just codes and computations that somehow represent ideas like circles and squares and dogs and cats, right? And we haven't yet talked about cognitive psychology. That's chapter 14. But certainly that is the dominant theme of modern cognitive psychology, beginning in the 1940s and 50s as computer science emerged as a thing, that we are using this concept of the computer, a digital computer that computes and represents information as codes, as numbers, that's maybe what the brain does. But this is not what the Gestaltists would argue here. They would actually say that, yes, there's a circle in your brain somewhere. It seems outlandish, perhaps, to say that. But that's what they mean by saying when they say that the brain fields are taking on they're taking on a shape that gives shape and structure to your consciousness, because it's the shape of the brain field that determines the shape of the object that you perceive. This is called the principle of isomorphism. Think of that, what that word means. Iso means same and morph means shape. So it means same shape, right? So the idea is that the shape of the object that you're thinking about, the circle that you're thinking about, corresponds directly to the shape that the brain fields take on when you think about that. I'm drawing this connection here of the difference between digital and analog devices. Think about what that means. A digital device is something like a computer, right? It's called digital because it uses digits, it uses numbers to code information and to compute and calculate information, right? But we don't have to think about computers. We can think of other kinds of digital devices. Think about a clock, for example. You could have a digital clock on your computer desktop, for example. You might have a digital clock, and that says something like 10:00, which is a code, and it means 10 o'clock, right? But it's just digits. It's just a code. It's an arbitrary code, right? We can invent any kind of number system, but we've got the one that we've all agreed on, and we say, okay, it's 10 o'clock, and we're going to use this sequence of 1000 to represent that particular code. But analog clocks are different, right? The analog clocks are the ones that have a minute hand and an hour hand, and the hands just kind of spin around on the clock face. And certainly there's numbers on the clock face that'll work as a code, but there doesn't have to be numbers on the clock face, right? You can still tell what time it is just by looking at a clock and looking at the position of the hands, even without numbers or symbols there. And what's also important is that the way in which the clock hands move is important, because a digital display doesn't actually move, right? It just represents a static number. It says 1000. It doesn't say, it doesn't move. And what's important about movement and with time is that time passes. So in a way, it is a form of movement, right? And the movement of the hands on a clock, their movement is analogous to the passage of time. And that's why it's an analog clock, because there is a direct and analogical relationship between the movement of the hands on the clock and the movement of time, or the passage of time. Another example is to think of the speedometer in your car. You might have a car that has both a digital and an analog speedometer, right? The digital one is the one that just says 50 mph, which tells you that you're going 50 miles an hour. Again, it's a code and it's just a static display. But then there's also the analog display, which has the needle that can move up and down on a dial. And again, the rate at which that needle moves up and down the dial mirrors the acceleration of your car. And so it's an accelerometer, right? And it's an analog device because it provides in a more analogous fashion information about the rate of change of the speed of your car. So in that way, we would say that these analog devices have a more direct relationship to the thing that they're measuring, right? An analog clock measures time in a more intuitive, analogous way. A regular needle on a dial speedometer measures the speed of your car in a more intuitive, analogous way. And the Gestalt psychologists are saying that the brain and the brain fields and the principle of isomorphism are measuring the world in analogous ways and taking on shapes that then determine the conscious awareness that you have, so that your conscious awareness now is analogous to the world. It is no longer, as opposed to modern psychology, modern cognitive psychology at least, it is not a coded representation of the world. It is a direct, analogous relationship to the world. It's a little bit abstract to think in those kinds of terms, right? But think about that. And that's where we're at with the Gestalt approach. Of course, keep in mind that these are ideas that are being developed in the 1920s and 30s before digital computers existed. And so cognitive psychology is going to come along eventually and kind of replace this kind of thinking. But nevertheless, this is where they're at in this time frame. And that wraps us up for chapter 9.